You wonder how Bitcoin addresses can be transformed to the Hash160 representation? In this video we will use Python and a nice little Bitcoin library to achieve that. It should be fun. Hey, what's going on, guys? You installed a Bitcoin node, dumped all the data from the blockchain and extracted all Bitcoin addresses, and now you want to transform all these addresses into the Hash160 representation. Why, you may ask? If you want to do more blockchain research and use awesome tools like Brainflyer, you need the addresses as Hash160. Maybe you can come up with some other reasons. First of all, we will install a virtual environment for Python. By doing that, we will have a robust development environment and won't mess up our Python installation. And I will put all the necessary commands in the description below. I already did that, I installed it, but I will type the commands now so you can do the same. So first of all, as always, we update. And then we upgrade. Okay, now we install Python pip. Oh, I had a typo. So I already installed it, so yeah, that's fast. After that, we install some things we need for a robust Python environment. I just paste it here. I also already installed that. And at the end, we have to install the virtual environment. Okay, so now we go to our main directory, home directory. I'm already there. And I did that, but you have to create a directory called environments. I don't press enter because I already did that. So now you go to this environments directory, and after that you create a new virtual environment by typing Python 3. That's important, Python 3 -m venv virtual environment, and I called my virtual environment Bitcoin. You can call it whatever you want, but if you follow, it would be easy to call it also Bitcoin. You press enter. Now the virtual environment is created, and you can control that by checking that the Bitcoin directory is here. And now you go to no, or you don't need to. So you type source Bitcoin, the Bitcoin directory, the bin directory, and activate. Source activate. Here you see there's Bitcoin. That tells you that you are in this virtual environment called Bitcoin. Let's have a look at this nice little library on GitHub. It's called Bit, and with this library it says the name is Bitcoin made easy. You can easily transform addresses, create wallets if you want, and such things. You can install it by typing in this command. It's pip install bit. It's easy. I already did that. Depending on your operating system, you can get an error that some dependency is missing. Just pip install the missing dependency and you're good to go. So let's do a quick test if everything is working. Okay, so just okay, we typed in import bit and we don't get an error message, so everything is fine. As a side note, the code we will write today won't be very robust and also not production ready, and won't win a beauty contest. It will work and can be a starting point for further development. And I won't overcomplicate things, and it's on you to sanitize input, handle exceptions, and so on. Before we start coding, let's look at a diagram and understand our goal for today. So here I have it. Here's a diagram. So our goal for today is to start with a Bitcoin address and end with a Hash160 representation of that address. So you can see here, this process is not of interest today, but we start here. We have this Hash160 representation. We take the version byte, in most cases 0 for the mainnet, put it in front of this 20 byte string or 20 byte Hash160 address, and we double hash this here. You see it 2 times the hash, and from the result we take 4 bytes and put it at the end of the starting point here. This is now Base58Check decoded, encoded. Excuse me, Now you get a Bitcoin address in the most popular representation. What we will do today is we start here and go this steps backwards. We decode this address, strip off the 4 bytes, for the checksum, and the 0 byte or the network ID byte, and end with the Hash160 representation. And for example, I just randomly choose a Bitcoin address, and this is the Bitcoin address, like this one, and we will end here at the Hash160 representation. No, that's done then here. Okay, so let's start coding. We exit the Python environment interpreter, and we create a directory. Let's say Bitcoin. No, we create a directory. I just call it scripts. I have to create it first. So, and enter the directory, and let's call the file address to hash160.py. First of all, we just take this address, copy it, and create a string. Let's call it Bitcoin address, and just paste it there. Now we want to decode this part, like here. We want to reverse this arrow, and we have to decode as the basic base58 decode. Yeah, that's what we want to do. If you have a library like this bit and want to check if how this library works, normally there's a documentation you can check, or if that's not enough, or you don't like the documentation, you can check if there are tests, and in the tests you can always see how the library should be used or can be used. So now our goal is to decode this address or decode. So we find a file called test base58 and just look into the file how this is done here. Okay, so you can see they have functions like b58 encode, b58 encode check, b58 decode check, and as we know that this address is in base58 check format, it's a good bet, let's say, that this function will be of use. So let's just copy this line and oh no, this was right. So and just use just import this function and check what we get if we put our Bitcoin address in to this function. Okay, so print base58 base58 decode, excuse me, check, and put in our address, Bitcoin address. So just let's see what we will get. Python. Now we want to transform that bytes to hex, and we can do it with a function already in this library, in this package. And I found it by looking at the tests, and at the test utils there is a function used called bytes to hex, and I thought that could be a good candidate for our address, and we will import that function. And we can do it by typing in the following: from bit.utils import bytes to hex, and now we can use this function. And we will make here another step. We will say like address bytes equals to base. We will put this here at in a variable to make another step. Decode check Bitcoin address. Okay, so now we can say address hash 160 equals to, now we use our function we just imported, bytes to hex, and feed our address in bytes to this function. Okay, and just let's see what we will get. Okay, address hash 160 is not defined. Let's see. Address. Oh, okay. Address. Oh, I just wrote a typo at the time, made a typo here. Okay, that looks good. And if we look here, they're just the version bytes at the beginning, and the rest is already the hash 160 representation. To cut off these two zeros, we can take like the string and start at the third position. Let's omit the first two and try again, and now we get the address. This is the Bitcoin address in Base58Check format, and this is the hash 160, and now we just get that. Okay, that's it for just the transformation. But at the last videos we get files. We extracted files from the blockchain with millions of addresses, and if you want to transform all the addresses at once, like you want to start and wait 20 minutes and come back and have a million addresses or a lot of addresses transformed to hash 160, you have to automate this process. And my approach is to just in the Linux command line to pipe these addresses to our script, and the script will output it to the standard output, so we can write that in a different file. So we tweak our script to just do that. Now we want to import sys because we want to read from the standard input. And let's see, we can delete that, and we say def for a function. We've defined a function, and let's call it address to hash160. What else? hash160, and we give an address and get a hash160 representation of that back. Okay, so let's see, we're here, just forget that. That should be address. At this point we are assuming that the input is a well-formed Bitcoin address in Base58Check format, and that's not robust because user can input everything, but we just assume that, and if you want to make this program more robust, you have to deal with these cases. Okay, we forget that we want to return this address. So, and now we just want to read from the standard input for line in sys.stdin. Just print to the standard output address to hash160, and in line here we have, then we assume the address, and that should be it. Just test it. There's echo. No. Echo, that's okay. Echo that and pipe it to our program. Python. Okay, we get an error. Okay, I think because at the end of we have to remove the new line. Yes, okay, now we just echo this to our script and get this in return. To avoid such things, if like there is a new line, we can, and avoid this error, we can just put rstrip here, and this will strip every white space and new line and so on from the string line. Okay, just check it again and take this command without the removing of the new line, and it works as well. Okay, so now we could pipe a lot of addresses to our script and save the result in a different file. I will just do that. I don't know where the file dump. Okay, like addresses, test addresses.txt. I think we used that. Just say cat test, no, cat test addresses.txt. Okay, there we have 10 addresses, and if we want to transform that to hash160, we just do pipe that to our script, and our script is in scripts address, and now we get the corresponding hash160 addresses, And if you want to save that to another file, just address in hash160 or whatever .txt. And now if you cat this file, no, that was okay. You have the addresses in a file. So now you can transform everything like I said. Okay, that's it for today. Thank you, and keep coding.